Just wanted to do a quick tutorial on how to connect LED light strips, such as these, which you can buy online. These are 3528, I believe, 0.08 watts a piece for each LED element. The way these work is you have a copper bus bar, basically printed on a flexible substrate, and there's a common negative and a common positive rail. On the positive rail, you have a current limiting resistor, because these are designed to operate at 12 volts, and the forward voltage on these LEDs is probably a third of that, probably 3.7 or so. But basically, negative rail is common, and then you have triplets of LEDs all along. And so there's 1, 2, 3, and a resistor, 1, 2, 3, and a resistor. And if you look at the way the tape is on these, in essence, you've got common rails on either side, and then a triplet circuit that connects each set of 3 LEDs through the current limiting resistor to the positive rail. So a lot of times you'll get these and they come on a big spool, and often they're sold with controllers and power supplies and other things, and people assume that that's the only way you can use them. You cut them down, you mess them up. But the reality is you can cut these at every single third LED. And if you look on here, there are cut lines marked. And if you look, the contacts between the positive and negative are split between the two. So I just wanted to show you quickly how to do this. And in essence, you will cut along one of those triplet lines, and you'll see copper contacts that you can split in half on each one. The easiest way to do that is just with a knife, a sharp knife. So take my trusty, inexpensive Swiss Army knife here with a good sharp blade. Lay it on the table. Line it up with that line and make a clean incision all the way through. You'll hear it snap when you get it right. There we go. So now I have a single 12 volt capable 3 LED cluster with its own current limiting resistor. Now the problem is these are coated in some kind of rubbery silicone feeling coating that protects those contacts and the LEDs and the resistors from weather and contamination, shorting out, etc. So it's not really easy to do this, but basically what you want to do is split the rubber away from the substrate so that you can get to those metal contacts. So I'm just going to do that here. And you basically just want to wiggle your blade between the rubber coating and the actual printed circuit board, like so. And once you get a little gap there, that's really all you need, is just kind of trim it back. And then I usually take a pair of nippers or sharp side cutters and peel back the substrate, exposing just the rubber, and just snip the rubber. And so now it's probably hard to see, but there's basically a little gap there with the metal contacts, which are just copper, are exposed. And in essence, you just want to solder those together with whatever your power supply connection is. And if you look, they conveniently print the polarity on there. But if you get one really cheap one that doesn't have the polarity, your negative rail is the rail opposite the current limiting resistor. The current limiting resistor is always on the positive side of these. And there's contacts at either end. So if you screw up one side, you got another side to work with. So let's try, and I'm going to move the camera here for a second to give you a better view of what I'm doing. I'm going to tin these real quick with solder, and then we will attach some wires to it. I'll show you how you can power these up with a little test power supply. Okay. Now I am using good old carcinogenic, birth defect causing 6040 lead and tin rosin core solder. And essentially what you want to do is make sure your tip of your solder pencil is tinned. This one's really gnarly, so I use it all the time outdoors and on automotive stuff. But in essence, you don't want to overheat it, but hold your solder to the pad and just touch it, and you'll see it flow. Hold the solder to the pad and just touch it and let it melt, and you can tell when you get a good solder bond. And that's it. It's pre-tinned and it's ready to connect. So at this point, I'm going to grab 2 little short pieces of wire. Should have had these prepared ahead of time. If you don't know how to strip wires, you probably are going to struggle with this. Alright, so I got me a red and black just for standards and consistency's sake. And what we're going to do, I'll lift you back up here. Just gently roll off a little bit of the insulation here. That'll be my positive connection. Roll off here. This will be my negative connection. Give it a little twist to hold the wires together while we tin them. And here's one thing with soldering I see a lot of people do incorrectly, and they cause themselves a lot of trouble. The more solder you put on there does not make it a better joint. You basically just want the copper woven wires to be soaked through with solder and then have a good even coating on the surface, but you're not painting it. So sometimes it helps to get a little heat transfer. You basically lay your solder up against the wire, heat the wire and the solder, and you want to principally heat the wire and let the solder flow through. And there you go, it's perfectly tinned. Get another one, do the same thing. Now the tinning is important because if you don't, then basically solder's got to flow in and fill up that copper. The copper's going to wick away the solder when you try to attach it to something. So pre-tinning it means that it's already saturated, so you don't have to worry about trying to pump a bunch of solder into a joint that you're soldering and waste heat and potentially overheat the surface that you're trying to solder. So it just saves you a little trouble. It's the right way to do it. So I'm going to... Another thing that I see people do too much is they put too much wire on here. You only need a tiny amount, especially for something this small current. So I'm going to snip this off all but, say, a millimeter, maybe 1.5 millimeters. And it's a tiny amount, but it's well tinned, the wires are cohesive, and it'll make a good joint. I'll do the same thing with the other one. Prepare it. And then we'll be ready to solder them to the LEDs. Okay, so we'll take the spot, and you can see where we pre-tinned it. I'll move the camera in closer. It's a little hard to work here. You can see what I'm doing. But in essence, now that we have two tinned surfaces, all we have to do, say negative side is the side that doesn't have the resistor. We're going to heat up the wire and the pad and just let it melt in there. And then leave it to cool for a second. And then once it's cooled, it'll adhere. Same thing with the other side. We'll take the positive side, do the same thing. Heat it up for just a moment. Nice, shiny, good, hot solder joint. And that's it. So now we have wires attached to the LED. And if this were a string of, 10 feet of LEDs, it would be the same. We're going to take this now, and just for a test, I'll take the camera up here and show you. I got a little tiny, ancient Vench power supply set to output 12 volts. Because that's what these are designed to run on. You can see the multimeter here is measuring DC voltage. I'll check it, make sure my output's stable. We're at 11.94, that's close enough. 11.95, that'll be fine. And just like we did before, I'm not going to tin these. We're just going to do a quick functional test. But in essence, I'll strip off enough wire to poke it into this variable power supply. And if we got everything right, these will light up. Now if you do this and it doesn't light, you got one of a couple problems. Either one, your power supply is not outputting the right voltage. It might be too low. Another possibility is that you don't have good solder connections, and then the other possibility is that these are diodes, and diodes only permit current to flow in one direction. So if they don't light up, your polarity might be wrong. So while I'm using a bench power supply for this, any wall wart type power supply, any AC transformer that outputs 12 volts DC will work. And some will work with AC as well, but you'll get a flicker at 60 hertz, which is very fatiguing to your eyes and kind of unpleasant to look at. A lot of cheap Christmas lights do that. That's why people don't like LED Christmas lights. But essentially, we'll hook up the ground first, unscrew these little terminals, just to give us a functional test of the light. And you watch, as soon as I touch it, it should light up. And there we have it. So you got a bright LED lit off of 12 volts. There are many common wall transformers. You don't have to have a specialty LED driver for this. like a constant current supply, despite what they'll tell you. A lot of that stuff is marketing and convenience. You know, a cheap Chinese transformer like this that outputs the correct DC voltage and has sufficient current capacity will work just fine. This one's under voltage. This is 9 volts, so that would be about 3 volts for LED. These will light up at that voltage, but they'll be too dim. But any power supply you see like this that's switching, the heavy ones that have transformers, or the really light, thin ones like you have for your cell phone that are switching power supplies, will work just fine, as long as you don't exceed the current rating the power supply is rated for. So you can look at the specs that come with the lights when you buy them. You can look at information online on the type of LEDs. Pretty much the strip lights come in 2 common categories. You've got the smaller ones and you've got the larger ones. The small ones are 35/28s, the large ones are 50/50s, I believe they're called. But anyway, these draw 0.08 watts per LED. Okay, so if you want to do the math, I mean, it's simple multiplication division. Anyway, there's 3 LEDs on here, each one drawing 0.08 watts times 3. Okay, and then once you have the total watts, divide the wattage by the voltage, which is 12 volts in this case, and you'll get the amperage. And as long as your power supply has sufficient amperage, they'll work. They'll light up and they'll run for 30 to 50,000 hours. So if you look in this room, this is like a workshop for me. I've got these LEDs just literally zip tied and double-sided taped to the bottoms of wire shelves, and when they're off, they're completely invisible. But in this room, that is the only source of light, is those LEDs. And this represents about a total of, I don't know, $10 worth of material and some leftover power supplies I had. So it's a fun little project. You can use them for under cabinet lightings, you can use them outdoors if you get the outdoor rated ones. All kinds of ideas that you can do. I've built flashlights and different things out of them, and they're great. They're inexpensive, they're easy to work with, very durable, last a long time, and they draw no power. They produce almost no heat. So that's it. Hope you liked the video. Comment, rate, and subscribe. Ask me if you have any questions, and I'll try to help you out.